Hi guys, welcome back to another Touchdesigner tutorial. Today we're going to be looking at doing a particle simulation using instancing inside of Touchdesigner. There's a lot of great tutorials out online already, but I'm hoping that today I can offer one that is approachable for beginners and at a bit of a slower pace, while also introducing a newer technique to develop more interesting shapes based on the audio that we input. A lot of these instancing techniques have very surface level or just have audio effects applied to post-processing, but we're going to be actually taking the different frequency responses today and interpolating that into position data. Don't worry if that doesn't make sense to you guys. I'm going to go through this bit by bit. It's worth shouting beforehand before we start out. Firstly, I'm fairly new to this, so apologies to any mistakes or inconsistencies I might have. Secondly, if you want to access this project file or any of my project files that I develop for YouTube immediately, you can just head over to my Patreon and support me on there. I've made it less than $10 a month just to be able to access absolutely everything. Just want to make it as affordable as possible and also just keep sustaining this going forward. But without further ado, what we're going to try to do is go by this project file one by one. But again, if you just want to get access to the whole file and start playing around, feel free to go and hit that link in the description. So what you can see right now is a very typical look for an instanced particle simulation Touchdesigner. I'm sure you've seen many clips on Instagram and YouTube and everything that look similar to this. But sort of what we're going to be doing differently today is if I take this audio oscillator and plug this into the pre-built analysis tool that we will be using and then hit play, you can see that as this sine wave pulses back and forth between a specific frequency, we're actually interpolating that data into positional data. And if I change the frequency like so, it'll change along this and then also along different axes as we enter different frequency ranges. I'll explain all that as we encounter it, but for now I'm just going to disable the background like so, and we're going to start off from the very far left and just make our way through and explain what we're doing with each little step of the way. Cool. So first things first, we're going to look at these SOPs here. So in Touchdesigner, these SOPs are typically for object-based data. So what we have here is a torus. So we've just pressed tab and gone to SOP and gotten a torus, which is a three-dimensional donut shape in maths. You can pretty much use any shape here, like a square, a rectangle, or a sphere. If you want to get the exact result that I do, then follow along with what I do, but feel free to take creative liberties wherever. We'll make sure that we get the technique nailed down, but these are sort of just optional stylistic differences. What you then want to do is connect this to a sprinkle node. So the sprinkle is going to divide up the shape that we pass into a bunch of little tiny wee thousands of dots. I've set that to be equal to 10,000 here, and the way I've chosen to do that is have a count here which I can change this number of, and then this number multiplies by itself like so, but there's nothing stopping you from just typing in 10,000 here like this. If you're not sure how to assign data in that way, then you can just click viewer active and drag and drop it on like that. But again, if you don't know how to do that, it might be worth looking at a bit more of a beginner tutorial, or I can look to do at tutorials for smaller steps like that in the future. Just let me know. Cool. Anyway, so once we've done the sprinkle and assigned it to 10,000 little dots, you should have something that looks a little bit like this. We're then going to connect it to a null, which is just going to signify the end of our SOP chain, at least for now. Then we're going to go from this null and go to the chop tab and go SOP2, which will create this little dotted line like so. In this SOP2, we want to make sure that position XYZ is selected and your SOP should be set to the null that you have here. Yours will probably be null 1 as it's the first data point. Don't worry about any naming differences, purely because I've structured the file in a different way. Also, it should be worth noting that when I click on any of these nodes, feel free to pause the YouTube video and make note of any differences I might have. A lot of them are creative differences, but feel free to copy it down to a T if that's your preference, or just, again, download this exact file from the link below. So next we're going to connect this SOP2 to a math. We're actually going to skip past this now because this will be important later. Then we're going out to another null. From this null, we're doing the same technique to connect it to a top. So we're basically going from a SOP to a chop to a top, which is going to represent our 3D shape in RGB values. We want to make sure we set this data format from R to RGB, so that way we're getting all 3 bands of color data. Then I have this null here, which is just references the starting point in this feedback loop that we're going to create. So yes, then we want to connect this to a feedback node. Don't worry about this one, we can disable that for now, as that's an audio reactivity component. And then I have reset turned on, but again, I will show you later on what some of the differences here we can have by enabling and disabling reset. We're then going to split the path. So the first thing we're going to split it to is to a noise. In this noise, we want to go to the output section and set this to be just noise, as we're just going to make sure we're using the input to reference the resolution, not actually the image we're outputting. Then for this noise, you want to craft it to however you want in your liking. Make sure you turn monochrome off, and then feel free to copy all the data I have laid out here, but this will actually be just random noise we insert into our position data to spread it out in a particular way. So what you do here is completely up to you, and I'll show you later on how we change that to get different looks. We're then connecting it to a comp, the feedback going into the first and then the noise going into the second parameters, just by connecting it like that. And then by default, it'll be set to multiply. Rather than just using a multiply node here, we want to have these options available for, again, more stylistic choices down the road. So next I have it going to a math, and I've set the multiply by 10, just so that way we get the scale a bit bigger. You can do that under the multi-add tab there, and everything else is like default. We then want to connect it to a point transform. So this is just going to transform the RGB points into actual point information, which we can then represent in 3D space. I believe everything here is set to default. For the second input, so the weights input, we want to connect the math node to a threshold. I have my threshold set at 0.585 right now, and then a math with these values here. These are values that we can play around with later for more stylistic, but feel free to just copy what I have under the multi-add tab, and everything else is as per normal. Cool. And then connect that to the weights inputs of the point transform. So then we get the end of our feedback loop, and we want to make sure that, again, I have it disabled right now, but we drag this end onto our feedback like so, or just into the target top when we click feedback like there. But again, for how we have it currently looking, I have it set to off. Oh, sorry, set to on. Cool. And then connects the end to another null, and that's going to act as the point we plug into our geometry data here. So we're next going to want to create a rectangle point. So there's, again, a lot of different ways we can do this. Essentially, we're going to be picking the material for the thousands of little dots. So you might want to do rectangles or circles. You could even do particles and then use points from that. But this is how I'm doing it. So we're just creating a new rectangle from SOP. I've made it a really, really, really small size like this. And then I've connected the output by right-clicking and then going to comp and then going to geometry, like so. And what you will see, if we are able to actually zoom in on it, but we probably can't, is that we basically will have one tiny little wee rectangle. The next things you want to set up is you want to add in a light under the comp tab as well. I believe everything I have is set to normal. You want to add a camera. Don't worry, do not copy this information. This camera information purely came from me clicking onto the viewer active and then interacting with it like so. So you're welcome to click on this and then interact it, but don't bother to copy these exact parameters that I have there. And then finally, you want to do a constant, which is under the materials tabs. I have deform on, like so. I have the rest set to this, and then I have the alpha level quite low, which just gives it a bit of transparency, which I quite like. Again, bit of a stylistic difference. And then we want to go back into our geometry tab. So again, everything on the transform page here is set to normal. But under instancing, so the third tab here, we want to set this to on. And that's where we want to drag our last top onto this and translate the OP. You then want to set the translate X, Y, and Z to R, G, and then B by either typing that in or clicking these drop downs repeatedly. This is essentially going to what we call instance this data. So for each little point data that we have represented here as a top, it's going to create a rectangle and display that in 3D space like you're sort of seeing here. If we did this with a 3D shape, you would see a bunch of 3D little nodes, but that might be very computationally intense, so don't recommend doing that. The rest we can leave as is for now. And then you want to go ahead and add in a render. And the light, camera, and geometry should all automatically point to this one render like so. If not, you can select the from here. The star sort of just means select all lights, but in this case we just have the one. Cool. If you're in the free version of Touchdesigner, your resolution output will be limited to 720p. Right now I'm just using a slightly upscaled 1080p version by typing in these values here, but 1080p will be plenty fine for most people. You can also try different like square formats or 9:16 ratios, all sort of listed below. All right, now we're going to go ahead and do some post-processing. Then we're going to loop back to the sort of start and talk about the audio interactivity. Sorry if my voice is a bit dry. I'm trying to do a bit more of a just approachable tutorial today. Yeah, sort of just like trying out a bunch of different angles, seeing what works best for people. So please do leave feedback if you get the chance. Cool, all right. So from this render, we're going to connect this up to a bloom. So this bloom I've actually gotten from the palette over here by clicking this button in the top left of the screen. So a palette in Touchdesigner, if you're not familiar, is a bunch of pre-made tools. And when we go into the image filters, we can see bloom sitting here, and we can just drag and drop that into the project file. Essentially, if we double click on this, you can see it's a pre-made series of nodes and also sometimes shaders and custom bits of code to sort of create this one interactive node, which is very useful. And there's some really, really great tools and techniques in here that I highly recommend you explore. So this is sort of up to you as to how you want to make it bloom. It's basically a glow. In this case, I have the intensity assigned to a high value, but we'll come back to this later. I have the threshold extremely low, so that way most of the image glows. I've set the glow color to white by clicking on that and then selecting white. I've turned off the ramp glow because I don't really want that hue. And then I've set the bloom to about 70% and then the glow level to about 0.3. And then the rest, blur turned down, I believe, a bit from default, and the rest you can sort of copy for yourself. I then have it connected to a feedback, which is, in this case, another one of the nodes made here. I have the dry mix turned all the way up, and then the opacity sent to almost 100%, but not 100%, which is just going to let these particles stay, once they appear, like hold that position for far longer, which will allow us to see a lot more of them. You can also play around with the ordering of these, do as you want. I then have it connected to an RGB delay. Personally, I'm not much of an RGB delay sort of person, but I'll show you what this effect does. For now, I have the dry/wet mix set to 0, which basically is as good as turning it off. This is another tool from the palette over here. Finally, I have it connected to a comp. This, what I have here is some noise. I've set the resolution to match my resolution from the render, and then I've set the noise to the following parameters, which you're welcome to copy. Essentially, I'm just adding like the sort of static that you might normally see. You can also add in a transform here, but we'll just skip past that today as we're doing a beginner's tutorial. From this noise, we're going into a level, and this level, I have the black level turned up, the brightness turned down, and then the rest as per normal. You could also just play with the opacity, do what you want. And then I'm adding these together, which is just going to give a bit of a grain. And then finally, I like to connect it to a null. maybe call this null background. Sorry. And then clicking this display button here to display it as our background. And what I'll do here is press play and actually show you that if I go back to the RGBA delay and slowly turn this up, we don't have much movement at the moment, but if I play the audio oscillator, you can see there we had a really nice delay. Yours will look slightly different. If you want the exact colors that I do, copy these parameters. And if I plug in a audio file, you can see we get a bunch of nice cool looking colors there, and you can sort of play around with these colors here to get different kinds of looking delays. And I believe the more traditional one would be something like that. But yeah, that's essentially it for post-processing. If you've followed all the steps that I've outlined so far, you should have a similar looking little guy to this like this. You might have the camera in a different position by clicking that interactive on the camera and then sort of playing with its position like that. But otherwise, everything should be pretty similar. So we can see now, if we just quickly go back to the noise tops, that if we change some of the noise parameters, it sort of plays around with the different effects like this, turning up the exposure, maybe turning down the amplitude. And then if we go to the composite, which is combining the feedback with the noise, and we set this to different parameters, you can get a whole bunch of different shapes. And this is just essentially just throwing noise into the mixture of the torus shape that we initially initialized. And if we turn off reset, you'll see that this all fades to black as we have that feedback loop going. But that's why I have it set to on for now. I'm just going to undo those changes just so we had what we had. But feel free to play around with these settings until you get something you like. And then now we're going to move on to the audio reactivity component. So I'm pretty happy with how this looks. So let's go up to our audio, which is in the green here. So the first things first is you want to do either an audio device in, which will be your microphone or like a audio interface if you have such. You could also drag and drop an audio file into here. If you want to learn how to route your Spotify, for example, through these projects in real time, please let me know. That could be a really interesting tutorial for me to show off. Or your final option is to create an audio oscillator, and that will just allow you to pick the sort of wave type that you want here. If you don't know much about music production, I would stick to audio device or audio file in. In this case, I'm going to do audio file in because I believe I'm just using the stock input like so. I'm just going to disable this by clicking this bypass here. Then we're connecting it to the audio analysis tool, which is one of these tools from the palette that we just talked about earlier. Everyone has different ways of analyzing audio in Touchdesigner. I wholeheartedly believe for beginners, this is the most effective and easy solution. It's a great tool where you can just plug in your audio information like so, click this to make it interactive, and then you can interact with the UIs, toggling on all these situations, turning the thresholds up and down, and playing with all these parameters. If you want to copy my exact settings, you can see them here on the right. But essentially, you definitely want to have the low, the mid, and the high enabled. Set the thresholds to a low enough value where when we click play and then we turn on the song, you can see all of them being triggered at some point, and then play with the smoothing to your liking. Not super important. You also want to make sure, optionally, that the kick is toggled on and that the threshold is set to an amount where it is actually triggering at the right points. We've then connected it, in my situation, to an audio in. You don't need to do this. This is just in case you wanted to have another audio source from an external outside project plugging in like so, but you can actually skip this if you want. Then connect it to our first select. So on the select, we want to click this drop down and then select low, mid, and high, or you can actually just type out low space mid space high. That will essentially, now when we play the song, you'll see it selects the data and normalizes it between a number of normalizes it to a value between 0 and 1. It's not exact, it can go over, but that's sort of what it tries to approximate the values between. We can also use math nodes to enforce that normalization, but we're not going to get into anything complicated like that today. We then want to connect this to a rename. This is technically optional, but I highly recommend you do it. So we're going to do from star, which is just saying we're going to rename all of our values in the same order we laid out, to tx, ty, tz, with a space in between. That's essentially saying we were going to make the low equal to the translate x value, the mid equal to the translate y value, and then the highs equal to the translate z values. So it should be worth noting that we've actually using the low, the mid, the highs, which is EQ bands inside of this node, which when we zoom in, we have these audio filters here with these exact frequency cutoff resolutions. And in layman's terms, they have a section for the low parts of the song, like the kicks, a sections for the mids, typically vocals, and then highs, like your hi-hats and snares. These are sort of 3 groupings and not specific frequencies that we're going to sort of approximate into position data. If you want to get a lot more precise, then please play around with the audio filter settings and create a bunch of different filters that you feed your song into, and then take that position data and plug that into your song. For this situation, using the approximated groupings from this tool is totally valid in my opinion. Cool, so then we want to go ahead and insert a new select like this, and we want to drag and drop the rename onto it. This is going to create this little dotted line and allow us to drag this all the way over to back where we created the torus SOPs for the first time. So we can see that I have it here. We haven't done anything with the select, except we've plugged it into the second position of this math node that we created earlier and glanced over. We're then going to, in the math under the first tab, go combine chops and set this to maximum. Again, that you can try any of these values that you want. I find the best results being from maximum. Essentially what that's doing is that from the SOP here, we have the translate, they have X, Y, Z values. We're then going to multiply each of those X, Y, Z values, or get the maximum of the 2 values in the XY position. Basically saying that when we get data passed into these values here from the song, it's going to manipulate the position data. And when I enable it, like so, you've already been seeing it act in the background, but you can now see this is how it's actually physically affecting the node like this. Apologies you can't hear the sound today. I'm trying out my phone's microphone because I don't have a good PC microphone. If you look at my other tutorials, they're very low quality. I'm working on getting my own microphone, but this is a temporary solution that I'm trialing out for today. But yeah, this is essentially the secret source of this tutorial. There's been billions of different tutorials on audio active particle simulations, but a lot of them will just take the audio data like kicks and then maybe cycle through these operations like this on each kick, which can create some really cool options, like as I just scroll through them quick like this. But I think it's a bit like too abstract for my liking, because but that being said, you can also combine those techniques with this sort of audio frequency data. And if you look at some of the other particle simulations that I've done, where I've created like a perpetual movement, you can propel those perpetual movements with the audio data and sort of create like unique movements and unique particle simulations purely based on the song that you plug in, rather than it just being the same movements repeated over and over again with no matter what song it is that you plug in. So yeah, again, that's the secret sauce. I have another little wee select going out from the audio analysis here. This is just grabbing all of them in this case. And we don't need this math, but this is when you saw the bloom earlier, we have the high value here. So I've gone ahead and clicked the plus here and dragged the high onto like that. And then I've done a little bit of math. So I've added a +4 beforehand, so it always has a base intensity of at least 0.4. And then I've made sure to multiply the high value by 3. Essentially what this is doing is every time the high frequency is being outputted, the intensity of the bloom is also increasing. So it's not just manipulating the particle position. If I disable this, this is just the particle being manipulated, and this is purely just a post-processing optional effect. Totally not necessary, but at least can possibly give you some ideas to steer you in a cool direction. From here, there's so many different creative liberties you can take. If you're familiar with Touchdesigner, I'm sure you can think of a million and one to already do. You can maybe rotate the camera with this ABS time code that everyone loves to use. And we could even do that if we set that to, say, times 30, make it a bit faster, make it across all three, why not? I believe I might have, I don't know if the recording's still going, but my Touchdesigner did not like that and just crashed. Well, perfect chance to leave to end the tutorial. Maybe don't mess around with those settings as much. But if you've enjoyed today's videos, a like and a subscription, if that's all you can afford, was very greatly appreciated. Please send me feedback, hit me up for any questions. I want to make sure these tutorials are beginner approachable, but also offer some new techniques. So sort of trying to balance that direction out. If you want access to this file or any of my files every time I release them, you can go over to my Patreon. I'm currently trying to do like at least 3 to 4 files a month. I have this massive pack catalog of wealth to share, in my opinion, so I want to make sure it's as accessible as possible. But otherwise, thank you so much for watching, and I will catch you in the next video.